data science is the most popular major with about 2,000 students enrolled every year in a little under 10 courses. And our data science students have probably heard the words, please open your Jupyter notebook so many times that they dream about it in their sleep. So suffice it to say, they're very familiar with the ecosystem. And one of these courses that uses Jupyter is Data 101, our data engineering course, which covers different topics such as relational algebra, Postgres, query optimization, data preparation and modeling, MongoDB, and concurrency. And our team of presenters today, unfortunately, Lisa and Christy couldn't make it, but me, Michael, and Jonathan are here, and we're the instructors and some of the TAs from the fall 2024 iteration of the course. So even though SQL is not native to Jupyter Notebooks, we decided to teach Data 101 using Jupyter because most of our students are senior data science majors. So like I mentioned previously, they're very familiar with the Jupyter environment. And our students get practice writing Postgres queries and Mongo queries using real-world data sets in 5 projects, each of which are in a Jupyter notebook. And as you can see from the screenshot here, they kind of work with 2 tabs. One tab is their notebook, Jupyter notebook, where the question is and where they can view the output of their queries. And then the other thing that they work with is a separate SQL file in which they can write their queries. And the main benefit to this is that we can utilize our existing auto-grader infrastructure. If you've heard of the software package Otter, that's what we use for auto-grading. And then the other benefit is because we can configure JupyterHub thanks to our great staff who support the JupyterHub instance at Berkeley. It comes pre-installed with all of the dependencies they need, like Postgres and Mongo, so they don't have to know what sudo apt install means or figure out which version of Postgres they need to install. So I'm going to demo the instructor workflow later in the talk, but for now, let's talk about the student assignment workflow. So to get started on an assignment, a student would go to the course website, click on a link, and then that will open their own isolated instance of JupyterHub in their browser using nb-git puller. And when a student works on an assignment, they kind of go through the cycle where they read the spec, they think about the problem, they will write a query either in SQL or Mongo. Then they'll run the query and view the results as a data frame in Pandas. And then they can run the public auto-grader tests using Otter. And let's say sometimes they might not write the query correctly the first time and the tests fail. So then they kind of go through this cycle again and again until all of their test cases pass. And then they can run a single cell at the end of their notebook that will create a zip file, which they can then submit to Gradescope. And on Gradescope, that's where we have even more like auto-grader infrastructure that will rerun all of the public tests. And it will also run the hidden tests, which will their score will be revealed to the student after the due date. So here's an example of what a student would see on their Gradescope portal when they submit an assignment. So for example, this is project 2. They can see how many points they got, and then a section with which tests were failed and which passed. And then they can also see like what the expected output should have been for the tests that failed. Okay. So in the past, what students would do is that we would have them write SQL queries directly in their notebook. And we did this using a package called JupySQL. And then what we'd do is we'd run the query from the database. It would display a data frame. And then we would store the result of the data frame in a pickle file. And then we would use Otter and load in the pickle file again. And if you're thinking to yourself, man, that sounds awfully complicated. Well, you would be right. It is very complicated. So that's why what I'm going to be presenting today is our kind of new updated grading workflow, which is instead of having this intermediate pickle file step, we just have a directory called queries that contains a bunch of SQL files so that students can write them in there. And then that's what we're going to run and grade in Otter. Okay, so obviously it's great to simplify the grading process and all, but what do students get out of this? So one really great pedagogical win is that we can provide skeleton code or starter code to students so that they have a place to begin, especially for queries that are super complicated. Another reason why skeleton code was really helpful for us in a huge course with like 400 students is that we could prevent these like common errors that students would run into. For example, we would ask them to create a view, and maybe they didn't quite create the view correctly the first time, and then they would rerun the cell and get an error being like, you can't redefine the view. So we can have these kind of things in the starter code where we drop the view first if it exists, or like another common mistake students would make is that they would forget to select from the view. So then we can just make sure we do that and also automatically add a limit because otherwise we would crash DataHub. Okay, another great benefit of having the queries in a separate file is that we could very easily reuse them. So for example, one of our projects is on query optimization. So we would often ask students to write the query and then rerun it using explain analyze, which will show the query plan and all of the statistics about how efficient that particular query was. And then the last main benefit that we got from this is that it was much easier for staff to check for academic misconduct because we are, they're uploading their SQL files, the actual queries that they write, and that's the thing that we're grading, as opposed to pickle files, which theoretically, if the students kind of knew how the grader worked, they could just copy and paste that, and it would be much harder for us to tell, as opposed to like the actual code that they wrote. And then the main downside to this is that students have to switch back and forth between a Jupyter notebook and a SQL file, but we think that the benefits, at least for now, outweigh the cons. Okay, so now in the last half of the talk, let's do a quick demo. You can feel free to follow along at this QR code or short URL. I'm just going to leave that up for a few seconds if people want to join in. And then and then now I'll switch over to JupyterHub. Okay, so as you can see here, this is DataHub, which is Berkeley's JupyterHub instance, and I've already, the dependencies are already pre-installed, and I've cloned the Git repository. And you can see in the root of the repository directory, we can see that there's a demo file, or sorry, a demo directory. So this is the one that I'm going to be showing you guys at the moment. And then if you open the Project Zero notebook, I've already pre-run the beginning cells, which kind of do what a standard notebook does. It initializes the auto grader and imports dependencies. And then I'm just going to scroll down to question 1. Okay, so here, as our quick kind of like warm-up question, this Project Zero is analyzing data from the Billboard Hot 100 database. And we can see in the queries directory, if we look at the 1a.sql file, we're pretending that maybe the student has already worked on this question. And then they're just selecting the number of rows in the table. So then all they have to do is run this and then see the output as a pandas data frame, and then run another cell in order to check instantly whether or not their query is correct. And then a similar thing for question 1b, which is a little bit more complicated, which you can see here, which is selecting any 25 rows from the Hot 100 table. And once again, we can see what that query looks like in a separate file. And then now let's look at a question that's a little bit more interesting, which is the selecting all the song titles and artists from the Billboard Hot 100 in November 2023 with a ranking of 5 or better, and then sorting that output. So if we try to run this file and then run the tests, it looks like the student attempted the problem, but they didn't get it quite correct. So let's take a look at what they wrote here. So let me zoom in a bit. Can anyone spot the mistake? And a hint is we only want the songs in November 2023. Yes? Yeah. So to repeat what was said, the error is that for our week ending, we have 2024 instead of 2023 here. So if we just change that, save the file, and then go back to our notebook, if I re-zoom out. OK, question 2. OK. Let me zoom out more. OK, and then, oh wait, that's question 1b. Okay, and then if we rerun it and then recheck the question, we can see that it passed. So this is kind of nice instant feedback for students. And then if we kind of go to the teacher side of things, how would we set up this notebook? If we go into source, project 0, teacher, and then project 0.notebook, we can see that there's a bunch of configuration for Otter. And then if we look at what question 2 looks like, on the teacher side, we can see that you can specify the number of questions, the solution code, and then down here we can see all of the unit tests that you can run on the problem. So yeah, that's just a quick overview of how we are able to set up Jupyter Notebooks for teaching data engineering at Berkeley. So yeah, I'll just go back to the slides. Over here. Okay, so yeah, that basically concludes my talk. Thanks so much for coming. And if you want to check out the code, it's free and open source at that link. And yeah, happy to answer any questions. Our emails are also there. And Michael at the top has free stickers for everyone for Data 101. So yeah, feel free to come up. But thanks so much.